All right, so here's another thing, and if you look, these addresses are here now. In some of the other simulators, I think you actually have to hover over some of them to see. That's not one. Let's see if this one is. Yeah. So like to get the start button, you have to actually um, hover over it. I thought it told us. I know it does somewhere. Where am I? Well, there we go. So so these addresses are there, but you do have to hover over it. So let's go back to the door. That's the one I want to play with. So that was interesting. Truck's already wanting to move, but you can see we've got sensors here. Some not sensors, but limit switches, and they're wired to input 1, 3, and input 4. So input 1, slot 1, bit 3, input slot 1, bit 4. And if you go back, this is what the cards look like. Input 1, slot 3, input 1, bit 4, input slot 1. Sorry, I get in a hurry sometimes, get sloppy. Input slot 1, bits 3 and 4 is where they're wired, and then output slot 2. So they're wired to these real world cards out there, just like we see here. And so let's go back to the door, wait for the truck. Thank you, truck, for all the noise. We appreciate it. And then we have all these switches here, input 0, 1, and 2. So all these are slot 1. Notice input slot 1, input slot 1, input slot 1, input slot 1, 1, 0, 1, 2, 3, and 4. And then we have outputs, and we have a motor up and a motor down, and we have the lamps. Outputs 2, 3, and 4 here. Outputs 0 for up and 1 for down. So just like we had in our paint drawing a while ago, um, different switches are wired to 0, 1, 2, 3, 4. Different outputs, motor up, motor down, lamp up, open, shut, and a jar are on the output card. So clean wiring, the device is there, but nothing telling it what to do, because remember, these are not integrated. We don't have a power source running through a switch, running through, um, well, we do, but we don't have it running to the device. We're not bringing power in through this switch to go motor up when we press open. We're not bringing power in to go through this switch to the motor down when we say close. We're just wiring those straight into the PLC bits that we've got coded here. So obviously, if we want to make the door go up, the first thing we're going to have to do is we're going to have to look at this open switch here. And the nice thing about this, if you right click and say edit symbol, you can type in OPNSW. And that way, when I look at that, I know that's an input because it's two parallel lines here. It's an open switch. And I'm going to say take the motor up. And I'm going to right click on that and say edit symbol. Motor up. There we go. So now I need to download this, and we need to see if it works. So it does to an extent, because when I press open, we see the door open, but when I let go and the graphics catch up and the sound and all this good stuff, we see it stop, because I'm having to hold that button down in order to get it, because it is a momentary switch. It's not one of those where you press it. See, it's only opening for as long as I'm pressing it. So we've got one little problem there, but we could take it a step further. We could build the close rung. And we're going to say if the close switch is pressed, we want to go motor down, which is an output. If you look, this kind of looks like a letter I spread apart, and these look like a letter O, so that's one way you can remember that these symbols are inputs and outputs. And we're going to say motor down. If I can drag that number over here. If not, I can hand type it. O, letter O, :2/01. This is like street addresses. So, you know, you got to have a slot. That would be like Lee Street. And then you got to have an address like 101, 102. Well, this is your address. It's an input. It's in slot 1 and it's bit 3, you know. So I can have an address that's just like saying take this letter to 101 Lee Street or 103 Lee Street. Um, it is an exclusive address that's tied to that bit. So let's download this if I hadn't already through all that talking. And let's see if we can now close it. And we can. So there we go. We can open it or we can close it. Now we're having to hold the buttons down, and that's one of the first things you're going to have to solve and figure out. And we could also, that's not what your thing's going to tell you to do, but we could also say if you're pressing the open button, have the open lamp on. So we'll come down here and add another rung. So if we're pressing the open button, I'll turn on another output, which is the open lamp, which is right here. And let's see if that works. Got to download it. And we're going to hit open, and the open lamp's on. And we're going to hit close. The close lamp's not coming on, but the motor is going down. We could add that. So we're going to say if we're pressing, I didn't name these others, but you get the idea. So whoops, I almost drug the open instead of the close, and we're going to do an output, and we're going to do the close shut lamp to show that we're shutting. And we're going to download this. We're going to run it. So when I press open, we get the open lamp. When I press close, we get the shut lamp. Now again, that's not what it's going to tell you to do. It's going to tell you to do it a different way. But you see the versatility that we've got already. Again, these are not physically wired to one another. They're looking in the PLC. And notice one caveat, once I put an output, let's name these outputs. Let me go back to program mode. Call that motor down. Begin. And 2.3 was open lamp. Open, spell it correctly. 2.4 was shut lamp. And 1.1 was the close switch. And notice it'll make both of them say close switch because we're using that address more than once. And there we go. So we've got that taken care of, and there's a whole lot of other things you're going to do. But the one thing I was wanting to point out is once we put an output in a rung, we can't use that same output again on a different rung, because the way a PLC works is it scans all the inputs. So it looks and says, all right, these inputs are either on or off. We either got the switch pushed or we don't. And then it writes to the output. So for instance, if you had that same output down here again, and this is in one of my other videos that's in your lessons, last guy is always going to win. If the first rung is telling it to turn on, the second rung down here, the next rung that has that same output is telling it to turn off, it'll be off, no matter. Or if the first rung is saying be off and the last rung is saying be on, it's going to be on. So once we put an output in a rung, we've got to modify that rung to account for whatever it is we're wanting to do to that output. So in other words, what I'm saying is we would just have to add more code to this particular rung right here. So if we wanted a second switch to make that motor go up, we don't have anything. But if I wanted to say if the stop switch was pressed, which would be pretty stupid honestly, but just to give you the idea of what I'm wanting to do, if I wanted to say if open or stop switch is pressed, go up. So now either one of these is going to make it go up. I didn't create another rung down here with that same output. I modified this rung's terms to do that. So again, you normally wouldn't use the stop button to make something go up. But see, the stop is in one state, and now I've set the place on fire because of that. The stop is in a closed state all the time rather than open, so it's just going to keep trying to go up all the time. But you get the idea. I would modify that rung to do that. Or I could even go as far as saying change it to an XIO, examine if open. Now I would have to actually press it to get it to close. So the stop switch is closed until I press it, and then it's going to be open, and then that run would be true. So that's the nice thing about it. I can look at the state of switches and whether they're open or closed with this particular one. So I can open it now with either the stop switch or the open switch. Again, not something you ordinarily want to do, but anyway, it's the versatility that you have with a PLC.